It's a pleasure to see you again. Thank you for joining us for another discussion.
Thank you.
Today we want to explore the health message. And I wanted to start with a question. Why is it that the health message is such a fundamental cornerstone to your evangelism work?
Well, if you want to have a healthy mind, you must have a healthy body. And what you put into your body affects every organ and also affects your mind and your clarity of thought and your alertness. And all of these things contribute. And so we need to know what we put into our bodies.
It's often said that you are what you eat. Do you believe that?
To an extent, yes. You do come with some genetic baggage along the road, but there certainly is something you can do about it, even in the worst cases, even in old age. There are just amazing things that happen when you change to a healthier lifestyle. I've had people well in their 80s change their lifestyle, and such improvements that they even walked out of old age homes and went back to their normal living in their apartments.
Well, that's a good news message because it tells us that it's never too late to change your ways.
No, it's never too late.
So the body, even in old age, can respond positively to a healthier diet.
Yes, especially if you switch to an all-plant diet, then you can get some very dramatic reversals of debilitating situations, which you wouldn't get with a change that wouldn't be quite so drastic. Yes.
So you use the term diet. In today's society, we're bombarded with magazines and televisions and advertising about this fad diet and this other fad diet. And how is the eating regime that you're alluding to differ from all of these other diets that we're bombarded with?
I don't believe in a diet. I believe in a lifestyle. Because a diet is transitory. You have a fad, you are overweight, you go on a diet, you want to lose some weight, and you can't wait to get off it to get back to normal, so you can go round and rotund again and then go back on your diet. A diet is never a solution. You need a lifestyle change, a permanent change. And that's the difference.
And so by lifestyle change, with respect to the food that we consume, though, it means changing eating habits, what we consume, perhaps how much we consume, when we consume it, so that it's part of a new lifestyle change.
It's a totally new ball game. I mean, most people have one meal a day, all day. And, you know, I compare it to a washing machine. You have your washing machine doing its thing, and then halfway through the program you decide, well, what about my socks? I forgot to put them in there. So you open the washing machine and you put them in there, and you continue your washing program, and then just before it's over you realize, wow, there's all of this that I haven't put in there, and you put that in there. And then you wonder why some of it is clean and some of it is just as bad as it was. The stomach is an amazing organ. It is charged with enzymes and acid secretions, and these have to be available when that meal comes in, because these cells all have storage structures, and the stimuli required to release these enzymes and fluids into the stomach is, of course, the food that you eat. So if you have meals spaced regularly apart from each other, that is the way in which to get maximum utilization of what you are eating. So this idea of constantly eating is something that leads to poor digestion, fermentation. And when you have fermentation, instead of getting simple carbohydrates, for example, you start getting fatty acids. That leads to an acid system. That again leads to a totally new hormone cascade. You have to neutralize the acids, so you have parathyroid hormones and all of these taking part in the transaction, calcium release from the bones, all kinds of scenarios. Whereas if you had regular meals, preferably starting with breakfast, and you know the old adage, you eat breakfast like a king, and lunch like a nobleman maybe, but supper like a pauper, that is a pretty good idea.
Now, what is the reasoning behind that saying? Why is breakfast supposed to be the biggest and most important meal of the day?
You know, if you had to take a particular quantity of food and say this is your ration for the day, and you did nothing else but eat the bulk of it in the morning and less in the evening, you would see amazing, dramatic effects. Obesity, for example, just switching to breakfast will have a major effect.
With the same ration size?
Exactly the same ration size. The reason is, in the morning, your metabolism is at its highest. In other words, you are geared to metabolize whatever you're going to eat and to assimilate it and burn it. Whereas in the evening, you are beginning to slow down your metabolism, you're going into sleep mode. This is all regulated by daylight and hormone cascades and from the brain reception areas. And then, if you're having a big meal in the evening on a slow metabolism, instead of burning it, you're going to store it. Firstly, you're going to poorly digest it, and that which you do digest and absorb, you're going to store it. So it leads to obesity. So just that simple switch. Breakfast should be a hearty meal.
And are there preferred breakfast foods that would constitute this hearty meal?
Well, what are the foods that we require? Firstly, in a breakfast, you want to have energy into your bloodstream quickly, because you've just come through a fast. That's why it's called breakfast, break the fast. And fruits and grains are probably the best that you can consume in the morning, because foods like vegetables take longer to digest. So fruits and grains would make the perfect breakfast.
But what about eggs and cremo on your porridge? And if you want energy quickly, how about a slab of chocolate? I mean, those deliver energy too. Why would they not be a good hearty breakfast?
Well, if you had a slab of chocolate, you would have a high sugar component in there. And there would be no fiber, no natural fiber in that. So what you would have is you would have a glucose surge. You might as well take a cup of coffee with no sugar. Just the caffeine itself will stimulate your adrenal gland. You will start releasing cortisones and adrenal secretions, which are conducive to the fight and flight mechanism. And so you'll have a massive release of glycogen from the liver as a glucose surge. You would have the surge and then not the activity. And you would have a drop to lower than normal levels, and you'd be lethargic. That's why these things are addictive. You need them again and again and again. So if you make chocolate or coffee or any one of those, by the way, chocolate also has caffeine-like components, theobromine, then you'd have exactly the same response. So you would be on this addictive roller coaster of hypoglycemia.
And so if you go on this roller coaster of hypo and then hyperglycemia, that may cause lethargy and you may not have the energy level, but why is that unhealthy?
Well, not only, this is very fascinating that you're talking about it. If you have a glucose surge, your cells have to be protected against that glucose surge, particularly your brain. Your brain needs very constant glucose levels, and that's the only energy source that the brain will use. And so you want this steady, perfect supply. If there's a surge, the brain needs to be protected, and the body protects itself by releasing huge quantities of fat into the bloodstream. So the triglyceride levels rise dramatically to protect yourself. When you do that, when you add a fat surge into the blood, automatically you change the consistency of the blood, you change the viscosity, and so that affects your blood pressure, for example. Not only that, the fat coats the red blood corpuscles, and they tend to clump together, 2, 3. Now obviously, if you're looking at my hand, I've got 2 surfaces here, so a red blood corpuscle also has 2 surfaces. If I clump 2 together, I've reduced the surface by half. If I clump 3 or 4 in a little train situation with trucks on it, I reduce it even more. And that, of course, leads to less oxygen exchange, and then you get that droopy eye syndrome. And so the next thing you do is you try and boost yourself, and you go through the same roller coaster. So it affects your blood vascular system, it affects your brain, it affects your storage of nutrients. All of these are affected. So what you want for breakfast is a whole food diet. You want fruits, you want grains, and you want foods that are whole food. In other words, all those fibers are in there. And there are 2 kinds of fibers. You have soluble fiber, and you have insoluble fiber. Now the insoluble one, well, that helps with the consistency of the food as it passes through the intestine, and helps you not to be constipated and all of those issues. But the soluble one is very important, because the soluble one clings to sugar. So as you digest your food and you have these free carbohydrates, the soluble fiber holds on to that sugar and releases it gently. So as the food passes through the intestine, there is this constant slow release of glucose, and you're pumping along with a regular supply of what you need. Whereas if you have a surge with no fiber and a drop down to hyperglycemia, you're active for a short period and miserable for a long period. And that is not what you want.
So let's explore hearty breakfast a bit more. I remember back in the 50s as a young boy, a hearty breakfast constituted thick slabs of fatback bacon, fried in a cast iron frying pan,
Yes.
breaking 3 or 4 eggs into the grease, splashing the grease on top to cook the sunny side up eggs, and actually dipping your Wonder white bread into the fat to eat it for the flavor. And we used to line up as kids at the stove to do this.
Yeah.
Now, I'm fortunate to have made it as far as I have when I look at the medical knowledge we have now about that kind of a diet. But still, from my experience, from my perspective, that didn't seem to hurt me as a child. I grew up a normal childhood, and here I am in old age now. So what's wrong with that kind of hearty breakfast?
I'm sure at some stage in your life you got it back with interest. Because that's what happens. You know, we have this notion, and society is steeped with it. Where do I get my proteins? I need protein. We're protein fanatics. And if there is a meal, nobody asks, hello, what vegetables are we having this evening? What are we having for supper? Oh, we're having, carrots. And come on, what are we having for supper? We're having chicken or this or that. It's always the protein, never the carbohydrate that's mentioned. Now, when we look at our human bodies, the structure is largely protein and minerals. The bone structure is calcium and phosphorus and all of that. But the structure, the musculature and all of that is protein. So we have this notion, since I consist of protein, therefore I must eat a lot of protein. But that's like saying that a motor vehicle, a car, that consists of metal must run on metal. So you put ball bearings in your tank or something. It doesn't work like that. The machinery, the actual machine, consists of largely protein and fats, but it runs on carbohydrates, just like your car runs on fuel. So the fuel that your body needs is carbohydrate.
But isn't it true that the basic food groups include protein and that we require protein in our diet?
Yes, but in the old days they used to have the standard plate divided into 4,
Yeah.
and everything had to be sort of in equal quantities. We only need 0.75 grams of protein per kilogram of body weight per day. That means that the average person never needs more than 60 grams of protein. And the average first world country consumer consumes 4, 5, 6, 7 times that much. Now, the body has no capacity to store that protein. It cannot store protein. We store fat and we store carbohydrate. The carbohydrate we store as glycogen in muscle reserves and in the liver. And the fat, well, anybody can see where that's stored, right? So those are the two we store. The protein that we consume in a day, that is utilized for body repair and small portion of growth, if you are growing. So a child, instead of 0.75 grams, would perhaps need 1 gram per kilogram of body mass. That means a child weighing 40 kilograms would only need 40 grams of protein. That's still less than an adult, right? It's not much, it's very little. Now this is the hazard. As soon as you have 3-4 times that amount of protein in your body, you're going to break that down into the amino acids. You have an amino acid pool going around, but your body needs carbohydrates. That's what it runs on. That's its fuel. So the only thing you can do is to change that protein to a carbohydrate. And we have the enzymes to do it. But here's the problem. In a protein, you have nitrogen in the amino groups. In a protein, in some of the sulfur-containing amino acids, you have sulfur. So now when you change those amino acids to carbohydrates, the nitrogen must be detoxified because it comes off as ammonia, highly toxic. I mean, we use that as a cleaning agent, right? So toxic that the body immediately detoxifies it to urea, which is also toxic. And if that were to accumulate and your kidney weren't to function, you would die from the toxic load. That's why people with renal failure have to go onto dialysis machines to get rid of this toxin. So you're loading your body with a toxin. The sulfur is split out as sulfate. That's sulfuric acid. That's battery acid. So now you're sitting with a sulfur load, and now you have to neutralize that because your immune system requires an alkaline environment. Your cells require an alkaline environment. And your acid-base balance is very firmly regulated. So you're going to neutralize it by producing calcium out of the bones. And that has a long-term effect. And all of these toxic loads. And then proteins have ring structures, phenolic groups that are not in carbohydrates, and those are toxic to your system, and you have to get rid of them. So eating a lot of protein for breakfast gives you an acid load and a toxic load. Why do you need that? Whereas if you burn carbohydrates, what's the end product? Carbon dioxide and water. And our whole body is geared to get rid of carbon dioxide. All I have to do is breathe out.
So, a healthier, hearty breakfast is one that reduces the amount of protein
You
and
reduce the
increases
amount of
the
protein.
carbohydrates and whole grains.
Yes.
Okay.
You only need about 12% of that plate to be protein.
So instead of a 3-egg omelet, we should just have a 1-egg omelet?
Well, have your grains, have your nuts, because the ratios of the fats and the proteins and the carbohydrates in those are perfect. But besides that, the amino acid mix in those is perfect.
Compared to the egg?
Compared to the egg, yes.
So you're suggesting that animal protein is a less desirable source of protein than
yes.
what you get from grains?
We did a lot of research. I had a lot of graduate students, and we had a research team working on a comparison between plant protein versus animal protein. And it doesn't matter what parameter we tested. If they had the plant protein, they were always streets better off than those who had the plant protein, and then those that had the animal protein. And the interesting thing is, immunocapacity was tremendously boosted. Energy levels were better. The fat profile was perfect in terms of cholesterol profile, HDL, LDL, the good versus the bad cholesterol ratios were absolutely magnificent. Fascinating. Even the sexual parameters, sperm counts, sperm motility, sperm abnormality, all of those were dramatically improved if it was plant protein.
But the test animals you used in these experiments, were they herbivores, naturally plant-eating, so that when they ate animal proteins, they just weren't adapted to eat
We
and
used
digest
the whole
animal
environment.
protein?
We used the whole range. We tested it on carnivores, we tested it on herbivores, we tested it on omnivores. One of our experiments was based on the vervet monkey, which is probably the closest in terms of metabolism to the human. And the results were so dramatic that it caused quite a stir in the scientific environment.
In one of our earlier discussions, you told us an anecdote about your graduate students referring to you as the prophet. Could you share with us that story again?
Well, you know, I would tell the students, I want these animals now to be on different regimes. This group you put on a plant protein diet. This one you add so much animal protein in the mix, that one more, that one more, that one more, and then I tell them, all right, when you do your analyses, you will find that this one is the best and that one will be the worst. But common wisdom told them it should be the other way around. And they were really determined to get the opposite results, but they never did. And so, yeah, that's a label that they gave me then. It had nothing to do with prophecy, of course. No.
But you knew beforehand, based upon these principles, what the outcome of the experiment would be.
Absolutely. Absolutely.
So coming back to protein for a moment. So animal protein is less desirable than plant protein.
Absolutely. But, you see, there is this notion that an animal protein is a complete protein. Complete in the sense that every amino acid that we require is in the animal protein, which is not the case in a plant protein. They're all there, but the ratios in any one particular plant are not the best for giving you an overall profile. But if you put plants in combination, a grain and a legume, if you put that together, you have a perfect protein. Because what the one lacks, the other one augments. And there's another very important thing about plant proteins. Plant proteins are very high in the amino acid arginine. And arginine is basic to our detoxification system because it is the introduction amino acid into what we call the urea cycle. So if you have high levels of arginine, it empowers the body to rapidly detoxify. Whereas plant proteins give you this, animal proteins don't. And so the ratio of the amino acids that you find in plants is far more conducive to a better system than you find in animal proteins.
But it's a common argument used by those that still want to consume animal protein rather than reverting to plant protein, that it's so complicated and it's such a bother trying to get this proper mix of amino acids and making sure that they remain healthy with the proper balance, that it's just not worth the bother. Give me my eggs and bacon.
It's actually so simple. Who has not grown up with a peanut butter sandwich? Every kid loves a peanut butter sandwich. Now, that's a legume and a grain. Lentils and rice, that's a legume and a grain. Any of the, and some of the legumes, by the way, are actually complete proteins. For example, chickpeas, garbanzo, that's a complete protein. Some of the grains are complete proteins, like millet, for example. So there are grains just by themselves that will give you everything you need. And some of them are very easily digestible. Millet, for example, it's easily digestible. It has a complete protein, and it's an alkaline grain. 3 things in one. So for elderly people, that's probably the best thing that they could consume. Oats in combination with a few nuts, perfect. That's why a muesli or a granola or just an oats porridge with a couple of nuts in it is a perfect protein for the day. And the great thing about oats is that it has a very high component of soluble fiber. That's why, you know, when you cook it, it goes thick and goes like that. That's the soluble fiber. So you can have it with dates. Have you noticed that a date is tacky? Now, this is where I believe creation makes more sense than evolution. If you take the fruit plants in the world, if the sugar content is high, then automatically the soluble fiber content is high. The sweetest thing you can get is a date. That's why it's tacky. It's rich in soluble fiber. So if you sweeten things with dates or with raisins and things like that and cut down on the simple raw sugars or even honeys or any one of those, and rather sweetened with the others, you would have an energy breakfast second to none. And you can ask athletes, that's what they have to do. I mean, in the old days, you had your bacon and egg breakfast and you tried to run a marathon, and then you'd have some guy who had oats and a banana for breakfast, and you wonder why you're left so far behind. And so the athletic world had to change its diet. Just think about, well, tennis tournaments, Wimbledon. In the old days, what did they have? They would drink cola drinks. All right? And then they would give them the power. And then the match went on, they were dead ducks. So they realized, okay, this rapid energy boost, this caffeine push, this glucose surge, it's very transitory. It just lasts a short while. So then they started switching to power drinks and something a little bit more balanced with minerals, etc. And then they gave that up. What do they do these days? They sit in between rounds munching bananas. So they've come all the way to the banana. Why? Here you have sugars mixed with a soluble fiber. You have the gradual, slow release, rapidly goes into the bloodstream, but at a controlled rate. And you have that energy to carry on with what you're doing. So, you know, I always say to people who ask advice, what do I do for sport or that or the other? Dates. bananas, raisins. Those are your energy foods that will sustain you without giving you a surge, and you will run for miles, kilometers before you will run out of that steam.
If what you say is true, that eating less animal protein is better than eating more, isn't it logical to conclude that you shouldn't eat animal protein at all?
Well, I am absolutely convinced that we shouldn't have animal protein.
Now, why is that?
Well, firstly, because of the amino acid mix. Plus, if you have animal protein, you have all the other dangers that are associated with it. And today, we're living in an environment that's not as it was in the old days. It's not business as usual. You know, in the old days, diseases were very specific. Bird flu was bird flu. Swine flu was swine flu. Horse flu was horse flu. Cat flu was cat flu. Dog flu was dog flu. And the viral encephalitis that you had, that caused brain fever, they were, you know, confined to the species in which these viruses flourished. Not anymore. We've had, in the last decade, a dramatic increase in trans-specific viral attacks. So that means that not even your free-range animal is safe anymore, because a virus doesn't discriminate as to whether you're free-range or whether you're not free-range. That is besides all the antibiotic-resistant bacteria that we have because of the way animals have been conditioned to antibiotics. These days we have all these trans-specific viruses. So bird flu is now a human killer. Swine flu is a human killer. And these are all kinds of problems. Have you ever heard of bean flu?
No.
Tomato flu? Cabbage flu? Lettuce flu? Doesn't exist. So, in terms of food safety, in terms of bacteria that can be pathogenic, you don't have that problem with any of the plant proteins. And, you know, society has progressed along this line to such an extent that you're not going to be shortchanged. You can go to any supermarket, you can pick a rice milk, or you can pick a oat milk, you can pick a soy milk, you can pick whatever you like. Today people are writing in the newspapers and writing in the magazines that soy is bad for you because it contains estrogens, and you'll become effeminate and boys shouldn't drink it. Well, have you noticed that the whole of China is effeminate? I haven't noticed that at all. And it certainly didn't affect their reproductive capacity. And that's all they eat. So there's this confusion because soy, well, and other legumes as well, contain what we call phytoestrogens. And they mimic estrogens, but they don't bind in the same way that they bind. There are alpha binding sites, beta binding sites, and they will only target one of those binding sites. And then they tend to be anti-carcinogenic. They tend to be positive in every single parameter, because there's always a balance that we need in any body, and there's always an anabolism and a catabolism, a building up and a breaking down, a positive effect and a negative effect, what we call a push-pull mechanism, and that keeps everything at a constant level. And so what these phytoestrogens actually do is they are always on the positive side rather than the negative side. So there's nothing wrong with soy. And if you're allergic to soy, well, there's rice milk, oat milk, whatever. It's all available these days. It's not a big deal anymore.
I've heard arguments against the vegetarian diet by avid carnivores that yes, you can find toxins and contaminants and hormones in meat, but you find it in plants too. Look at the California produce that caused all this sickness because of the E. coli contamination. So on the surface, the argument seems to hold water, but I guess it's true that you can, with proper kitchen hygiene, you can wash your lettuce so that it's clean and still healthy, but you can't wash E. coli from meat because it's right inside the meat
It's
product.
right
Is
inside.
that true?
You have a good point.
Yeah.
But besides that, if you take the way in which animals are treated, whatever medication you give to an animal is internal.
Mm-hmm.
Everything is dissipated through the entire system. Whereas when you have plants, it's external. A pesticide is applied to the outside. You don't go and give your plant an injection, do you? Mm-hmm. No. So everything is on the outside. Then plants also, that's why if it rains, the farmer has to apply it again. Mm-hmm. So if you wash it, you are still better off in many cases, even if it has been sprayed and the legal requirements of marketing and spraying have not been met, you're still better off because of a process which we call biological magnification. So you could have a field over here and the farmer is spraying, and the wind takes that spray and deposits it on a field many kilometers away. And let's say there's 1,000th of the concentration on that field than what was sprayed. Animals come and they eat it. You have your cattle grazing. They eat that. They concentrate it in their bloodstream many thousands of times. So you can actually have higher levels of these components in animals than you have on something that is directly sprayed. Because the animal tomorrow has to eat again. Mm-hmm. And the day after has to eat again. And so there is this biological accumulation that takes place. And then in the feed industry, when they feed, in the old days, carcass meal was rampant. They used to use that. Fish meal is very common. All of those are again concentrated in that next layer. So you have far more probability of contamination from an animal product than from a plant product.
Even in our modern society where groundwater contamination is becoming such a serious and important topic, isn't it true that the plants could suck up groundwater that's contaminated and thereby become toxic themselves or polluted?
Yes, it is to an extent true, but plants are geared to absorbing minerals and water. They are not as geared by their root system to absorb organic compounds. Mm-hmm. So if you have an organic farming situation and you have manures and you have all of these things out there, then the bacteria break that component down, and the acids they produce leach the minerals out of the soil, and the plant absorbs those minerals. Whereas if you have an animal situation, you're actually feeding those compounds, some of them which are toxic, directly to the animals, so they're assimilated into the body. So simply put, a plant growing in manure does not assimilate manure. But an animal being fed manure would assimilate manure. And I mean, that's common practice, feeding manure in many cases.
So cut out the bacon.
I would say yes, cut off the bacon.
But what about eggs? Now, they're an animal product, but surely the egg, being contained within a shell, is protected from that kind of contamination. So
No.
isn't that a good source of protein?
Well, the egg is probably one of the top contaminants for Salmonella, Campylobacter. Any one of those pathogenic bacteria will mostly come from there, because if the hen is contaminated, she will incorporate it in the egg. That's the first place she'll incorporate it. So that doesn't mean that the egg will be perfect, right? And an egg is very high in cholesterol, extremely high in cholesterol, and you could actually do without it.
But we see on television on a daily, weekly basis, get cracking, have your eggs, good source of protein, hearty breakfast, energy source. You're suggesting that perhaps that advertising is a little off the mark.
I am not only suggesting, I'm saying.
You're saying it explicitly.
I'm saying high protein, number one, high fat, high cholesterol. All of those components are in there. Is that how you want to start your day? And if you think how many hidden eggs there are in foods, if you take pastries and cakes and all of those components, then you will have a lot of that around. Whereas if you have grains, if you have fruits for breakfast, nuts, then what are you getting? Are you getting a saturated fat, or are you getting plant fats? And nuts mainly are high monounsaturated, and then some polyunsaturated, but always packed with antioxidants. Animal protein and fat combinations, not packed with antioxidants. So you have free radical formation, and this type of diet is then associated with colon cancer, pancreas problems. High fat diets are associated with diabetes, colon cancer, breast cancer, ovarian cancer. Those are the fat-induced cancers. It's not the way you would want to start your day.
So let's see, we've eliminated bacon and we've eliminated eggs. What about milk? The arguments and the wisdom, conventional wisdom is it's a good source of calcium, it's a source of energy, it constitutes an important element in a hearty breakfast.
You really want to go there?
I think we should, because there's so many people that still think that milk is an important component to a good diet.
Yes, that is to me incredible. We've done a lot of research on milk, and many scientific institutes all over the world, I'm talking about the best institutes on the planet, have changed that view of late. Milk is something that is for pre-weaned animals and humans, and it's pretty species specific. If you take the requirements of the protein and carbohydrate and fat mix in a particular milk, every single species is different. And if it's also directly related to the growth rate and the development of the organism. So cow's milk has more than 3 times as much casein, which is the protein, than human milk. So the ratio fat to protein favors the protein in cow's milk, and that's why cows have rapid growth. And they don't have to pass mathematics tests or be interested in calculus or philosophy or anything like that. Whereas humans have to develop the nervous system, and that requires a total different ratio of foods. And so for young children, human milk is definitely the best. And after human milk, which is geared for the brain development, you know that they've found that there's a dramatic difference between children that are raised on mother's milk and cow's milk in terms of the development of the brain, even IQ, all of those issues. So milk is something that is species specific, and cow's milk is for cows, human milk is for humans, but when an animal is weaned, it doesn't get any milk. You don't see any other animal trying to get its calcium needs satisfied by running after another animal's udder, do you? And ask yourself, where do the strongest animals on the planet that never get milk, like an elephant, where does that get its calcium needs for those massive bones that it has? Surely not from the grass, which has a mere 300 milligrams of calcium available per unit, compared to, let's say, over 1,800 for dairy. And this calcium is the number one thing that they will tell you why you need the dairy. You need the calcium. But because you're getting this high protein load, and the protein that is inside the dairy actually causes calcium loss.
No, excuse me a minute, though. How can consuming a calcium-rich food product
Cause calcium loss.
calcium to decrease in the body? It's counterintuitive.
It sounds illogical. You would think that getting this calcium into your system will favor the calcium going into the bones rather than coming out of the bones. But the body has only one response to acid load, and that is the hormone cascade of releasing parathyroid hormone, and that parathyroid hormone pushes calcium out of the bone into the blood. So if you're getting this protein casein, which is rich in the sulfur-containing amino acids, and you start metabolizing them, you might have a lot of calcium in that diet, and logically you would say that would favor calcium being deposited in the bone. But your body first has to respond to that sulfur load, and the only mechanism it has, it cannot produce the carbonate from the calcium that you're eating, so its natural response is to release it from the bone. And so you have...
To neutralize the acid created by the sulfur from the...
That's correct. And so if you had to take a small amount of calcium, like African women, they get about 300 and something milligrams of calcium per day, as opposed to 1,800 milligrams for the average American woman, for example. Much less. They don't have osteoporosis. They don't have decalcification. And they don't have the calcium deposition, which causes the joint pains and the guts and all of those. Because if your body has this calcium load, but the hormone cascade actually pumps more calcium into the blood from the bones, then that calcium must be removed. And the kidney only has a certain capacity. And so what happens, it's deposited. And it crystallizes in the joints. And that's what causes the deterioration and the pain, particularly when you get older.
Bone spurs and osteophytes.
That's right.
And things.
So getting your calcium from dark greens is the best way to get it. Because firstly, those dark greens are all alkaline. And so when you consume them, the calcium that is absorbed with that food has only one way to go, into the bone, with no concomitant release from the bone. So you are better off with a lower calcium intake from green foods than with a high calcium intake from milk.
So these facts are supported by empirical scientific research?
Absolutely.
Published research?
Absolutely.
And you indicated earlier in your comments that there are an increasing number of scientific research organizations that are conducting these studies and coming to this understanding.
Absolutely.
If that's the case, why is it that we still have the conventional wisdom taught to us by government, taught to us by schools in terms of the food groups, certainly communicated to us through magazines and advertising that we should be consuming a lot of milk, eating a lot of eggs. There's a disconnect there.
I've come to the conclusion that you can speak until you're blue in the face. It doesn't seem as if this message is going through. Because your plate is holy. You know, people say heart disease runs in this family. Diabetes runs in this family. But diet also runs in that family. And what is on the plate is what you have inherited from your parents, what they inherited from their parents, and that's what you're accustomed to. You can break that continuity of disease. So this is a very interesting point that you're mentioning. If you take, for example, the notion you must have dairy to fight osteoporosis. That's the notion. And you look at the logic and you look at the statistics and you ask yourself the question, why is there a direct correlation between dairy consumption and osteoporosis? And why is it that the top dairy countries, the dairy consuming countries like Norway, are number one on the hit parade for osteoporosis? If the dairy was so good, they shouldn't have osteoporosis, right? And now they have osteoporosis, so the solution is give them more milk. And it doesn't work. And
Which exacerbates the problem.
Exactly. I always compare it to a bricklayer. The bricklayer is building a wall, brick by brick. And let's say the capacity of the bricklayer is to put 1,000 bricks into a wall per day. And then you decide, well, there seems to be a problem and I want to actually have 2,000 bricks into the wall. So the best thing that you can do is get someone to supply this bricklayer with more bricks. So instead of giving him 1,000 bricks, you give him 2,000 bricks. But he only has the capacity to deposit 1,000. So the other 1,000 go flying past his ears and probably endanger him and slow him down in the first place, right? And that's what we're trying to do. We're trying to solve a problem by giving more bricks. That's not the solution. The solution is get another bricklayer, right? And that's what happens in the cells. You want healthy cells. You want healthy osteoblasts. You want healthy cells to incorporate the calcium into the bone. And that means you need more bricklayers and not more bricks.
Conventional wisdom is always conventional, but not necessarily wise.
No.
So the advertising we see, we should be healthy cynics concerning advertising and recognize that the food industry is a global, multi-billion-dollar business that has financial objectives as a higher priority than your health concerns.
That's right.
Yeah.
I've had these, when I was at the university still, and my students were involved in this research, and we would have discussions on television as to what happened. I would have regulatory bodies come to me and say, you better tone it down or else.
Really?
Yes, and you know, I'd give them the science and explain it to them. And they would have to admit that they're on very, very thin ice indeed. Then it's interesting, on one occasion, one of these individuals then stayed behind and came to me and said, you know, everything you mentioned, my family's got it. Do you think really this is the problem? And he had particular problems with his little daughter that was so sick. And I mean, dairy is associated with asthma. Dairy is associated with chronic ear infection. Dairy is associated with bronchial problems. And she had all of these symptoms, plus all the allergenic responses. He cut out the dairy. And he phoned me a couple of weeks later and he said, I cannot believe the difference. I have a new child, totally new. Let's look at it. Norway, the highest rate of osteoporosis. Then the next countries would be Switzerland, Sweden, Denmark, Holland. Those are the dairy countries. If you take prostate problems, the number one country, Switzerland. You go down the list, there's all the dairy countries. So there's something for the men, there's something for the women.
But Dr. Veith, I like my cheese.
Well, then have a cheese that you make yourself, get a substitute, and get used to it.
Mm-hmm. Make a choice.
Make a choice. You know what I like, for example, pizza. People say you can't eat pizza without cheese. I mean, how can you eat pizza with cheese, without cheese? We have pizza made and we put avocado on afterwards. Once you get used to that, you don't want to switch back to the other. Or you make a nut cream that bakes on like a cheese. It's so digestible. It doesn't give you that heavy feeling and that dull brain feeling that you get from the other foods. By the way, cheese is so hard to digest. Your stomach is an amazing machine. As your stomach digests food, it sends through samples through the pyloric sphincter into your duodenum. And in your duodenum there are receptors that measure the protein digestion. And if it is not complete, then it sends a signal and it shuts off the pylorus, right? So if you have cheese in your stomach, the food stays in your stomach much longer than if you have fruits. People say, I eat fruits, it doesn't satisfy me. I eat fruits and grains, I don't feel satisfied. Well, a feeling of satiety is probably the worst parameter to measure your diet by. Because you don't absorb anything in your stomach. This is just the place where the digestion takes place. You absorb in your intestine. In other words, you start absorbing once your stomach is empty. So if you feel satisfied, it means your stomach feels full, but you're not getting anything. So if you put a piece of cheese into your stomach, your food can stay there for more than 10 hours. Whereas if you had grains and fruits and those things for breakfast, 2 to 3 hours, that energy is available to you. And you're running, you're cooking, you're on your way. Whereas the other guy is sitting there, and if he's had cheese, 10 hours and longer, there it sits, nothing available to you. No wonder it's problematic.
So we started off the discussion about exploring the risks and the dangers associated with animal protein, talking about reducing the amount of animal protein. We got to the point where, in fact, no animal protein is better than less animal protein.
Yes.
And that included milk and cheese and eggs.
Yes.
So it seems to me like we've reached a conclusion that it's not a vegetarian diet that one should be aspiring to follow, but a whole lifestyle change to a vegan diet. And on that topic, I think we should take a break and then resume our discussion after the break about what really constitutes a vegan diet and how we can embrace that lifestyle change.
Perhaps I could just say, when I was at the university, the people knew that I'd changed to a vegan diet. And they had no idea as to what constitutes a vegan diet. No idea. They think that's what it consists of and you've become a rabbit. But we'll talk about that later.
Very good. Thank you.